Welcome back to my series of doing project Euler problems in Python, while talking about some of the mathematics or backgrounds to the problems. Here at problem 7 they ask us about the 10,001st prime number. Primes are interesting, and this is not the first problem that talks about those. The prime numbers being those numbers we cannot divide into smaller numbers the way we can divide 6 into 2 times 3. As the problem text says, the first few primes are 2, 3, 5 and 7. So which is the 10,001st one? Well, this rubs in our face that there is no easy way to calculate the next prime. If we need them all, then the only thing we can do is start with 2 and eliminate all numbers that are not primes and see what we are left with. The method I'm going to use comes from the old Greeks and is a so-called prime sieve. I will take a long list of numbers, long enough to contain at least 10,001 primes, and then eliminate non-prime after non-prime. Let me use an example here. If we start with a list of the first 17 numbers, skipping 1 because 1 is special, we will initially have them all as possible prime numbers. Looking at the first remaining number, we find 2, so 2 is a prime. We then mark all the numbers that are multiples of 2 as not primes, that is 4, 6, 8 and so on. Having done that, we start over again and look for the next number left on the list, that is 3. So 3 is also a prime number. Then we remove all multiples of 3 from the list, that is 6, 9, 12 and so on. As you see, we have actually already removed quite a few of them. Back to the start again, where we find 5, so 5 is the next prime number. And since all early multiples of 5 are already eliminated, let's add a couple more numbers to the list so that we can eliminate 25 as well. Actually, it's always possible to start marking at the square of the prime, but I'm not going to use that optimization this time. Now I just have to implement this in Python. Opening Notepad++ to write our small program. I do like how easy Windows makes it to split the screen between two programs. The first problem that faces us is a practical one. How large list do we need to contain enough primes? How many numbers do we need to start with? That is another excellent question with no clear answer. What we do know is that for the first million numbers there are approximately 1 million divided by the natural logarithm of 1 million primes. And for the first billion numbers there are approximately 1 billion divided by the natural logarithm of 1 billion primes. Approximately. So I plan to use that formula to verify that I have chosen enough numbers to start with a large margin just to be sure. So start with 100, and if that is not large enough, double it until it is surely large enough. Multiplying the estimate by 3 to give us a large margin in case the approximation is not good enough. Then I create a list that long, initially filled with just true. And true means that this is something we think is a prime, and false means that this is something that is not a prime. As always, I want to know how long the program takes. I don't expect this one to be instant, but I also don't think I can make it much faster. Well, maybe if I used the optimization I said I would not use. And print the length of the number array -1, which will be the same as the last number, which we know is also the last of our primes. And the answer to the question. Now when we have the list of true values, meaning that the number might be a prime, I will implement the actual sieve loop. For the first true value, we know that it's correct. That is actually a prime. Where did the list go? Anyway, just create a list of true values of appropriate length using Python's list multiplication operator. Very useful for things like this. When I locate the prime, I count it so that I know when I reached 10,001. And I mark all multiples as not primes. Skipping the optimization to start at the square of the number since I promised not to use it, though it would actually have been easier than I realized. If we are at the final prime, I cut off the isPrimeArray list at the current position and returns it. The caller can use it to check if any number is a prime, or check how long the list is to see how many numbers it has. That will reveal where the 10,001st prime is. So the code is slightly complex, so I'm adding an insert after the real code just in case I've added a bug. Time for a test drive. And I forgot to tell it which prime to look for. Let us start with the example 6 primes. And I had written a list access with parentheses instead of square brackets. Easy to fix. 6th prime was 13 as expected, but I also need to start the timer correctly if I want to know how long it takes. So now everything seems to work. Okay, 10,001, here we go. So the answer is 104,743. And that's our answer. Welcome back next time for more Project Euler. And as always, if you enjoyed this content, please like, comment and subscribe.